interview.
Hi all, welcome to interview preparation at 360 Digit MG. Hi, my name is Sheila. I'll be conducting the interview preparation session today. I hope I'm audible to everyone. So let's start the session. To begin with, as we all understand, this particular session is related to the interview preparation towards data science. Like all those who are trying to get a job or attend interviews related to data science, those people can be benefited with this session. And to go about it, yeah, let's go ahead with first question. Like we all know, it's related to data science. Let's understand how different it is with the other technology. Like let's understand the difference between AI, data science, ML, and DL. First, let's understand what is AI. It is artificial intelligence. Uh, we are quite familiar with this terminology in today's world. Seems like everything and anything that we do and in our daily life is somewhere related to the artificial intelligence. To be specific, it is an area of computer science that emphasizes on artificially introducing human intelligence into a system or a program. This is to mimic how a human behavior uh, works and how a human performs certain tasks. So the system can do that task and make human's life easier. This is specifically built on the technology as deep learning, as we all know this term. So deep learning. Let's talk about data science. So in this, we will understand that there are four terms: artificial intelligence, data science, machine learning, and deep learning. So from the broad perspective, the latter three, data science, machine learning, and deep learning, are all part of the AI in their own ways. So from the broad point, we have the first big picture as artificial intelligence. From that, we see data science, and then further inside, we see machine learning, and then comes the deep learning. In data science, it is again a subset of artificial intelligence, which focuses primarily on the data. Let me take out the document and make a note for all of you to remember and understand what these terminologies are. I hope my voice is audible to everyone. Yes. Let's talk about how each of these terms differ from each other. How different it is from data science, ML, learning, right? As we discussed, data science is part of artificial intelligence. It deals with specifically with the data, in handling the data, in trying to manipulate the data and see the patterns in the data. In data science, we try developing methods to store and analyze data to effectively extract meaningful insights from it. Whereas in machine learning, it is a subset of data science. Further, it is a subset of data science which focuses primarily on the building the models by using the data. That could be from the existing data or the historical data, sort of that. The models can be built in various ways such that they learn from the data and improve efficiency and using the reward and experience. We will come to that how each of these work. And in deep learning, which is again the subset of machine learning, which is used to build AI systems. It teaches the computer to do human activities that come naturally. So, to give an example, what exactly is deep learning works as is the speech recognition, driverless cars, or text generation, and all of these, as we see all of these in our day-to-day life, these are actually the part of deep learning technology. Okay, let's come to the next question. What do we understand by supervised and unsupervised learning? Hello? Sorry. Coming to the different types of machine learning models, the methods that we follow are supervised learning, unsupervised machine learning, reinforcement learning, etc. This will talk about supervised machine learning, unsupervised machine learning, and reinforcement machine. The font is not regular. Hope it is visible for everyone. Coming to supervised, this is something to do with our data where we have an output variable given to us. In this, both the output and input variables are known to us. And the output variable is used as a label data set for us to predict with using the new data. Using the existing data, we predict and we try to model, build our model in order to predict what would be the outcome or the class or the output value based on the existing data. So in this, we will have different type of supervised learning. Within this, we have classification, we have regression, and we broadly broadly classified into classification and regression. Let's make a note of this. We also have something called a recommendation, which is based on the user's preference from the large pool of options. And we also have retrieval. And in unsupervised learning, in this type, the output is unknown to us, and it tries to make sense of unlabeled data. So we call this as labeled data. And non-supervised, we do not have any labeled data, and we try to understand the underlying patterns in the data set. We understand patterns data set. All right. In reinforcement, in this further, we can see that there are classification like clustering, anomaly detection, association, and autoencoders. Further in reinforcement learning, this is less supervised and depends on learning agent determining the output solutions. This is we will get into deeper understanding on this later on. Next question, let's understand what is the term regression and classification. Right? Classification is used to produce discrete results. Okay, like we are going to take the data set, we are going to classify it based on certain criteria. As our model depicts the results, we are going to classify it based on the output variable that is given to us or the class variable that is given to us. This classification primarily produces the discrete results. It is used to classify some specific categories. For example, if a person has a cancer or not. Right? In classification, we get discrete get discrete results to identify cancer, yes or no, right? Or it could be 0 or 1 or positive or negative. Or any kind of classification problem you can think of. Holiday or no holiday. Something like this. And in this regression, this is mostly used for continuous data. It deals with predicting a certain price value or a specific floating number, which can be measured in the scale. So this deals with continuous data. Continuous data. For example, price, house, or weight of a person, weight, person, etc. Okay. Similarly, let's understand the next question. What is overfitting and how to ensure that model is not overfitting? Right? We must have come across this term overfitting and underfitting. Before coming to overfitting and underfitting, I want to cover this topic of training and test set. Okay, this is a very common question. What is training data and what is test data? Yes. Any questions? Any doubts on this or queries, please ask. Yes, what do we understand by training data and test data? Anyone? Yes? To put it in a very simpler understanding, any model when we are trying to build, we first take the data set, we do a data pre-processing, we try to look into the null values, we try to remove any outliers or we treat outliers based on the data available to us, and we look at the size and various constraints. in data processing. After doing the pre-processing, we perform the data splitting. In data splitting, we take portion of data as a training data, and we take the second part as a testing data. We typically do that so that our model can be trained on a training data and can be tested on a test data. So when we see the size of each of these, when we see the training data set, it is considered to be a larger data set than compared to the test data set. So we will never have a test data set bigger than the training data set because we want to ensure that the model that is built has all the required details on the features and their variances covered in the model. And then or after building the model, we test that and predict it on the test data. So that is the whole idea. Let me put it across here. Training data is used to train the model, and testing data is used to test the model for its accuracy. Used to test the model accuracy. Right? Now, let's see what's the next type of question we can cover. The important question is, what is feature engineering? What is the difference between model-centric and feature-centric? First, let's understand what is feature engineering. All right. Feature engineering is a process of extracting features from the raw data. The term feature is something to do with our columns or from the data set. We have number of columns. We need to understand which column is important for us. The feature, for example, in a data set of any decision tree or maybe a simple linear regression. If we want to cover, if you want to build a model where you want to predict whether the price, the house of the price is going to be certain value, we need to find out what are the factors that will affect um, the price of the house, right? So let me write it down. What is feature model centric and feature centric? What is the difference between feature centric feature centric and model centric? Let's understand this. So feature engineering is to do with extracting the features from a raw data, or as we know, the data could be in any form. It could be a structured data or unstructured data. Uh, Before we start using the data, we need to first perform certain changes to it before we can use that for our modeling. Which specific feature or which column or the which factor is going to affect my model much. So that we have to find out using feature engineering concept. Um, if we want to remove a particular feature or if we want to add any new feature, all of this is covered in the feature engineering. So coming to model-centric approach, here in this case, considering all the feature and building a complex model is called model-centric approach. Right? In model-centric approach, we uh, we we consider all the features given and build a complex model. Whereas in feature-centric, we try and select few features. We will not, if we are given 500 features to consider for our model, we will first look at the features which are useful for us. If there are any repeated features or the columns which will be duplicating the model, duplicating the other feature. So working around on whether to add feature or not and which works out the best for our modeling. So those feature selection and crafting and then building the model is called feature centric approach. So be careful, select the feature and craft it before modeling. Or before building the model. All right. And then I hope this is clear. Any doubts on this? Any questions? Please ask. Any doubts or questions on this? Yes. Right. Let's understand what is an balanced, imbalanced data set. Okay. What is an imbalanced data set? Let me put it here. What is an imbalanced data set? Anyone can answer this? What is an imbalanced data set? Yes. A data set is called an imbalance when there is no equal distribution of classes among data sets. For example, a number of observations per class may vary. It mostly occurs when dealing with classification problem. We see that the, the distribution of classes is not the distribution. First, this is basically a classification problem. Right? Here, this is the distribution of the classes are not same or not equal. For example, like for example, cancer, no cancer. Okay, how often do we see in a data set which detects or identifies model which detects cancer over no cancer? Like out of 500 records, we may see not more than not more than 10 or 20% of class saying no cancer, because many people whom we test who turn out to be no cancer, and there are less people who have cancer, right? So that is the idea. So this kind of, say, out of 500 records, you could probably see the class with no cancer would be more than 400 records, and maybe the lab or even 50 or 60 records could be with cancer. So these kind of data set is called imbalanced data set. Typically, it is used in the classification problem to identify a new record, whether it belongs to no cancer or does it based on the factors that are given to us. All right. For example, now like how do we handle this kind of imbalanced data set? What are the ways to um, avoid imbalanced data? How to handle the imbalanced data before building model. Okay, before building a model. All right. What are the ways in which we can handle this imbalanced data set? One of the ways, out of many ways, there are few techniques by which we can do it, is random sampling, random resampling. So once we get hold of the sample data, we will try and see using the proportions which class is majority and which class is minority. First identify majority and minority class. Now, what is majority and minority class? Like we discussed, cancer or no cancer. In this, we can say cancer as 0 and no cancer as 1, or the vice versa. If there are more people with no cancer, then we call that as a majority class. And when there are less people who have cancer in our data set, then it is called minority class. All right. In this, we will first identify how to handle that. There are different ways of resampling. This random resampling. In that random resampling, we have under and over sampling. For example, this random sampling is further divided into under and over sampling. All right. In under sampling, we look at the train data. This all of this is handled at the training data. All right. You will see that in training data set. Under and over sampling. What we do is we try to identify the majority class and we try to resample it. Resampling it in such a way that the majority class is further divided, or it can be resampled or reshuffled. All right. Then there is one more option called cluster based. We have an k-fold cross validation. We have SMOT. We have SMOT. We have ensemble techniques, ADA boost, gradient tree boosting, and extreme gradient boosting. Right. So these are some examples, not all of them, because there are quite a good number of techniques to deal with imbalanced data set. Okay. The most common next question, let's understand what the next question is. What the next question is, when we go to an interview, the very common question we notice is, what do you do if you have a data set with missing values or the data is not normally distributed? What do we do? How can we solve the problem with missing values? Any answers? Yes. Anyone? How do we handle missing values in our data set? Right? One way of doing it is imputation. Very good. Yes, imputation technique. Mean median imputation, right? Okay, that depends on the data set. Good. Okay, when do we apply mean imputation? When do we apply mean imputation? So we follow one way of doing it is Mean imputation. Okay. Imputation is one of the ways. Yes. In this, we have further mean imputation, right? Median, right? Mode, yes. Mode imputation. Good. And what else do we do? Okay, we are not talking about outliers here. We haven't got to that point yet. We are not talking about the outliers. We are talking about the missing values. Missing values in the data set could be null or an AN and empty spaces, right? How do we handle that? Right? Yes, good. One of the ways of doing missing values, handling the missing values is, yes, imputation, mean, median, mode. And for example, in a data set of like 100 records, and you have say about 20 features in it. So 20 columns you have with 100 rows. And out of 20 columns, if you have like 3 or 4 columns with more than 80% of missing values, are we going to conduct any mean imputation or median or mode imputation? Are we going to do that? Can we perform imputation or any other technique to fill the null values using that for more than 80% of the rows are missing values in 2 or 3 columns? How are we going to handle that? Right, so if we see we have to put a threshold as to how much percentage of missing values in a column you want to still consider and perform techniques to fill those empty values, or how much percentage you want the threshold value which crosses, like if it is 80% or beyond, uh, values in a column are empty, we choose to ignore that columns. We will not consider those columns for any kind of imputation or any other techniques to perform because it might not give a proper accuracy in our model. So we have to put a threshold. How many columns, how many rows in a column are we okay to have in order to consider that column for our modeling, right? So write it down. Threshold value to be considered in order to identify whether to conduct, whether to whether to conduct any techniques for handling missing values. right? That is the one. And next is okay. One more question is like, what are the techniques, or how do we, if your data is not normally distributed, how are you going to handle that kind of scenario? Out of your 5 or 6 columns, 3 of your columns are not normally distributed. How do we handle that? Question is how to handle the data set which is not normally distributed. Okay, ND. With ND I mean normally distributed. All right. Yes. Yes. What happens to your data set if your data set is not normally distributed and you're trying to build a model on it? What happens to it? Yes. So, ideally, as we all understand, whenever we conduct any regression, where the output column is our continuous data, we first identify that all our columns, which are numeric and are continuous, are normally distributed. We follow the line assumptions where linear, there is a correlation between the input and output variables. There's no correlation between the input variables, and all the input variables are normally distributed. This is one of the constraints in our line assumption when we conduct a regression technique. So let's understand that. We should check all the input variables are normally distributed. If they are not normally distributed, we perform transformations technique. So what are the different types of transformation techniques? What are the different types of transformations? Yes. What are the different types of transformation techniques? Yes. What are the different types of transformation techniques? Yes, and logarithmic, exponential, correct. Box, right. Polynomial, yes, you're right. Correct. So we have log transformation, we have exponential, we have square root, or we have reciprocal, right? We have exponential, shell, we have square root, and or reciprocal. Right. So these are the possible techniques that we have to apply if your data set is not normally distributed. And then coming to another, this is the last question. Let's okay. Let's understand what are the different data types available for us when we are trying to build a machine learning model. What are the different types of data types we follow? What are the different type of data types? Yes. So we know that the different type of data sets, right? So in this, with an example, let me say we have primarily in a broader spectrum, we have quantitative, and qualitative, right? In broad spectrum, we have qualitative and quantitative. In quantitative, we call it as continuous, that is continuous and discrete. Okay, continuous and discrete, right? Yes, continuous and discrete, structured and unstructured. Yes, correct. Balanced and imbalanced. Balanced and imbalanced data type. No, we can't call it as a data type. It is a type of data set that we can have, but it's not a data type. Balanced and imbalanced are not the type of data type we have. We can get quantitative and qualitative. In quantitative, it is about the discrete, or like we have the measures in that are discrete, whereas in continuous we can measure it using scale. I mean, the qualitative is discrete and quantitative is continuous. And further, we can classify it into structured and unstructured also, and time series also. So in continuous, we have, when we call a data set to be, or data type to be continuous, it is when you have the floating point numbers or a decimal numbers inside that. We call it as continuous. It is further divided into interval and ratio. Right? Right. Here, in continuous, we have further in interval and ratio. In discrete, we have basically discrete is nothing but the integer number or the real number where we can count or categorize it, right? So this is something like our binary classification, COVID or no COVID, cancer or no cancer, this kind of, you can count, and it could be categorical data. So let me write it out here. We can consider this as categorical, further taken into nominal and ordinal data. So these are the different data types we have. The continuous is further divided into interval and ratio, and discrete is further divided into nominal and ordinal. Okay, in interval, typically interval is very similar. When we compare, there is a very slight difference between ratio and interval. In ratio, we consider the universal scale, that is the global scale, and in interval, we focus on the local scale. Make note that these both of them are numeric values. For example, the example of interval is temperature, right? And ratio, the example for ratio could be any currency, weight of person, and things like that. And in discrete, we have nominal and ordinal. When we call it as ordinal, it is in a natural ordering. It comes whenever we perform any conversions, like any label encoding, converting the different levels, classes into different levels. For example, in a school, we have primary and middle school and high school. So these are called ordinal data. Whereas in nominal, it is basically the name given. For example, an ID. ID is also a nominal data. It's not an ordinal data. All right, these are the examples. Okay, I think we have to conclude it. I hope you all enjoyed the class session. In case of any doubts or anything, please let us know. All right, guys, thanks for joining. See you tomorrow again on the same time, the same channel. Thank you.